In this video, I'm going to talk about division of polynomials and end up with the factor and remainder theorems. We'll begin with a long division. We want to determine whether the binomial factor x plus 2, and after that x plus 3, is that a factor of the polynomial f of x equals x to the power 4 plus 5x cubed minus x squared minus 17x plus 12. So if I think about this, I have all the powers of x, starting at 4, then 3, then 2. So this is minus 17x to the power 1 plus 12x to the power 0. So I want to begin with my factor, possible factor. This is x plus 2. What do I need to multiply this by in order to get a leading term of x to the power 4? So that's x cubed. So I'm going to put x cubed right here. I'm going to multiply this through. So that is x to the power 4 plus 2x cubed. So that's x to the power 4 plus 2x cubed. I want to subtract that. So x to the power 4 subtract x to the power 4 is 0. 5x cubed minus 2x cubed is 3x cubed. And I'm going to bring down the x squared. So I still have x plus 2. And now I have to think about what do I multiply this by in order to get 3x squared. So I think if I multiply that by 3x squared, I multiply these two together, I'll get 3x cubed. So that will be 3x cubed plus 6x squared. So I've got to put the plus 3x cubed here. Now I've got to have 3x cubed plus 6x squared. I want to subtract those. So I have 3x cubed minus 3x cubed. That's 0. Negative x squared minus 6x squared. So that's negative 7x squared. Now I'm going to bring down the minus 17x. So I've still now got to think about my factor x plus 2, my factor x plus 2. What do I need to multiply x by in order to get negative 7x squared? So that is negative 7x. So when I multiply those through, I have negative 7x squared minus 14x. We're going to subtract negative 7x squared, negative, that's a plus, so that's 0. Negative 7x squared plus 7x squared. Then we have negative 17x plus 14x, so we have negative 3x. And now we're going to bring down the 12. So our factor again is x plus 2. What do we have to multiply that by? That'll be negative 3. So we have negative 3 up here. And this will equal negative 3x minus 6. And if I subtract these, negative 3x plus 3x, positive 12 plus 6, that's 18. I have a remainder of 18, which indicates the divisor x plus 2 is not a factor. So the quotient is x cubed plus 3x squared minus 7x minus 3. The remainder is 18. The divisor is x plus 2. And the dividend is f of x, that which is divided into. So x to the power 4 plus 5x cubed minus x squared minus 17x plus 12. So we're going to think of the quotient as q of x, the polynomial. The remainder we'll just call r of x. The divisor is d of x, and the dividend, of course, is f of x. So we know f of x equals the divisor, d of x, multiplied by the quotient, q of x, plus r of x. That's just the 18 that I've found here. Now let's divide x plus 3 into f of x is x to the power 4 plus 5x cubed minus x squared minus 17x plus 12. So x plus 3, I'm going to have to multiply that by x cubed. X cubed will go up here, and this will give me x to the power 4 plus 3x cubed. So x to the power 4 plus 3x cubed. I'm going to subtract that. So I will get 5 minus 3x cubed. So that's 2x cubed. Bring down the minus x squared. So my divisor again is x plus 3. I'll need to have 2x squared there. So that'll give me 2x squared here. And this will equal 2x cubed plus 6x squared. So 2x cubed plus 6x squared. I'm subtracting that, and this will give me minus 7x squared. Bring down the 17, so minus 17x. So x plus 3 is our divisor again, and I'll need minus 7x here, so minus 7x, and that'll give me negative 7x squared minus 21x. So negative 7x squared minus 21x, subtract that, and I'll get negative 17x plus 21x, that's 4x. Bring down the 12, so that leaves me with my divisor again, x plus 3. I'll need a 4 there, so plus 4, and this equals 4x plus 12, and that gives us a remainder of 0. So this actually means f of x equals the divisor multiplied by the quotient plus 0 in this case. So f of x in this case is equal to x plus 3 multiplied by x cubed plus 2x squared minus 7x plus 4. And whenever the divisor is 0, we have a perfect factor. So that means x plus 3 is a factor. It's a factor of our original function f of x. The remainder theorem states if we have a polynomial f of x that is divided by x minus c, then the remainder is f evaluated at c. So in the problem we just did, the first problem, we had the factor of x plus 2. If we have to put that into the format of x minus c, then it must be x subtract negative 2, so that we see c equals negative 2. I already put my function f of x into y1. Second quit gets me back to the home screen. So I'm going to evaluate the function at negative 2. I have variables, y variables, function. I put f in y1, so y1 is going to have to stand in for f. Then I'm going to use that parentheses, negative 2. Do not use subtract 2, use negative 2, and that gives us the result of 18. In the second example we did, we had the factor x plus 3. So that means, of course, that c is equal to negative 3, as we see here. We're going to evaluate f at negative 3, and that will give us 0. This is an illustration of the remainder theorem. Long division is just that. It is long. So I'm going to use this example to teach you a shortcut called synthetic division. We're going to do the same problem. We have the dividend, or f of x equals x to the power 4 plus 5x cubed minus x squared minus 17x plus 12. And in the first instance, we're going to use x plus 2. So we want to determine, is x plus 2 a factor? And we know that we have to get this in the format of x minus c. So that means x minus negative 2. So here's how we do synthetic division. I've got negative 2 here, that is the c value. And now I have to write down the coefficient of every term in order. So I've got to have the coefficient of x to the power 4, that's 1. The coefficient of x cubed, that's 3. The coefficient of x squared, that's negative 1. The coefficient of x, that's negative 17. And the single number, or the coefficient of x to the power 0. Then I have to bring down the 1. Now, this shortcut requires me to multiply negative 2 and 1 and put that here. So that's negative 2 and 1. So to clarify, my first step is to multiply. Then I'm going to add 5 plus negative 2 is positive 3. Now I'm going to multiply. Negative 2 times 3 is negative 6. This gives me negative 7. Negative 2 times negative 17 is positive 14. That gives me negative 3. Negative 2 times negative 3 is positive 6, and I'm left with 18. So my remainder is 18. So what I've actually found here using synthetic division is if I divide f of x by x plus 2, my quotient then, I've got to read off from this part, the original dividend, or the f of x, had the highest power of 4, so the quotient must have a highest power of 1 less than 4, so that's x cubed plus 3x squared minus 7x minus 3, and the remainder is 18. Next, we'll use synthetic division to determine if x plus 3 is a factor, so that means c must be negative 3. I'm going to bring down the 1, multiply negative 3 and 1, that's negative 3, so that gives me 2. 2 times negative 3 is negative 6. Add negative 1 and negative 6 together, that gives me 7. Negative 3 multiplied by negative 7 is positive 21. Now I'm going to add negative 17 and positive 21 together, that gives me 4. 4 times negative 3 is negative 12. The remainder this time is 0. So the quotient will be x cubed plus 2x squared minus 7x plus 4. The remainder in this case is 0. And the factor, of course, is x plus 3. So I could say f of x has the factor x plus 3 times x cubed plus 2x squared minus 7x plus 4. The factor theorem states that given a polynomial function f of x, if f evaluated at c equals 0, then x minus c is a factor of f of x. If the quantity x minus c is a factor of f of x, then f evaluated at c equals 0. Given f of x is x to the power 4 minus 5x squared minus 36, we want to determine, is negative 6 a factor? Is positive 3 a factor? So remember, we must have every power of x. We've got to have x to the power 4th, x to the power 3, x to the power 2, etc. So that means the coefficients would be 1 x to the power 4 plus 0 x to the power 3 minus 5x squared plus 0x minus 36. And now I can do synthetic division with negative 6. Now I don't need to change anything here because it's simply asking me, is negative 6 a factor? It doesn't give me x plus 6, but that's really what I'm concerned with part A. So negative 6 times 1 is negative 6. 0 plus negative 6 is negative 6. Negative 6 multiplied by negative 6 is positive 36. That leaves me with positive 31. 31 times negative 6 is negative 186, so that 0 plus negative 186 is negative 186. Negative 186 times negative 6 is positive 1,116. So when I add that to negative 36, I get 1152. So that certainly tells me negative 6 is not a factor. So the answer is no, it is not a factor. So is 3 a factor? Now we're considering x minus 3. Bring down the 1. So 3 times 1 is 3. And 0 plus 3 is 3. 3 times 3 is 9. Negative 5 plus 9 is 4. 3 times 4 is 12. And 0 plus 12 is 12. 3 times 12 is 36. Negative 36 and positive 36 is 0. So yes, 3 is a factor. From the factor theorem then, we know that f evaluated at 3 is equal to 0. We also know that x minus 3 is a factor.